So two-way tables are called two-way tables because they tell us two types of information, two different pieces of information, right? So there's usually one option along the top and there's another option along the side. So the two things that they're telling us on A is gender and preferred subject. Those are the two subjects. That's why it's called a two-way table. There's always two things that they're telling us. Okay, so the question is, do males and females have a different preference for math or English classes? Okay, so the two-way table summarizes data about gender and subject preference for a class of 25 AP Statistics students. Okay, so they asked the students, first of all, they got their gender, and then they asked them, which do you prefer, math or English? Okay, so you can see the numbers there. There's 25 total. So we've never really looked at a two-way table before, but a two-way table always has, again, like I said, the two things they're talking about, the two things they're comparing, and then it has totals, right? So the total here should match the total number of students or the total number of whatever it is. So 25 total. Okay. So you can add across, you can add straight down. Everything should equal the same thing. It's the totals go down and they go to the right. Okay. Okay. So then it says, suppose we choose a student from this class of 25 at random. So put all the names in a hat, reach in and pull one. What's the probability? So define event A as getting a male student. Okay, so that's important. Event A is choosing a male student. Event B is getting a student who prefers math classes. Okay, so A is getting a male student. So what's the probability that I reach in to the bag of names and pull out a student who's male, whose gender is male? What's the probability? How do I figure that out?
Total means divided by total number of students.
There you go. Yeah. Right. Probability is total at the bottom. So how many names are in the bag? 25, right? That's the total. The top is however many fit that, which they're asking. Male students. So we go to the males. Is it 8? No. Is it 2? No, right? It's 10 because that's the total number of males. So, and then reduce it, you get 2/5. You can leave it as a fraction or change it to a decimal. Either one's okay. Okay. Now, probability of A and B. A and B. So now we need to find, so what's the probability I reach into the bag and I pull out a student who is male and prefers a math class? So let's write this down. So the probability of A and B, right? The upside down U is and. Okay, so in other words, they're saying what's the probability that I reach into the hat and pull out one name, and that person is a male student, and that person also prefers a math class. Okay, so let's start with the total. How many is the total going to be again? 25. Still 25 names in the bag, right? So male and math. Male and math. Here's math. Here's male. 8, right? That's where the 8 comes in. The 8 comes into males who prefer math. Right? I don't think that can be reduced. When you change it to a decimal, it would be 0.32. Okay? So now we have to interpret this. So interpret it is where you can use a percent. All right? So if you use the word probability, don't put a percent. If you don't use the word probability, you can change it. You can change it to a percent. Okay? So I would say there is a 32% chance of selecting a male student who prefers math. That's what that number means. If I were to reach in the hat and pull out a name, there's a 32% chance that that student is male and likes and prefers math. Okay. All right, so that's a two-way table. I want you to do letter C. Try letter C. Letter C is at the very top of the next page. Same table. It's the same. So it goes with the same. It's just on a different page. So I want you to try C. We did and. Tell me or now. Okay, so this question said or, right? It had or in between A or B. Anytime you see or, anytime you're finding the probability of or, don't even hesitate, go right to this formula. Because this has the answer. That's what we're looking for, A or B, okay? So what we need to find is this probability plus this probability and subtract this probability. Well, some of them we've already done, actually. Some of those guys we've actually done. I think 2 out of the 3 we've already done in earlier problems, okay? So the probability of A, we did that, right? Yeah, it was 0.4, right? 40%, 0.4. We already did that one. So I'm going to write it down here. Okay. We haven't done B yet, so I'll skip B for right now. But we just did in part B right before, didn't we do A and B? 32, right? So all I'm missing is the probability of B. I could use the table to figure that out. B says students who prefer math. Students who prefer math, let's see, students who prefer math, the total is 20 out of 25. Which is 4/5, which is 0.80. Okay, so now I'm going to put that in for B, probability of B. So I add them together. Let's see, I add these two guys together. I get 1.2 and then minus 0.32, and I get 0.78. No, 88. 0.88. 0.88. So what that tells me is there's an 88% chance that if I reach my hand into the bag, I'm either going to choose someone who is male or someone who prefers math, right? Someone who's male or someone who prefers math. Either one. It doesn't have to be both, right? Both was letter B. That was both. Reach into and pick someone who has both. And or means one or the other is okay. Here's my next question. They didn't ask, but is A or B, are A and B mutually exclusive? So are A and B mutually exclusive?
No. In some cases they are.
So it's either going to be yes or no. It's not going to be like, yeah, so it either has to be yes or no. So what does mutually exclusive mean again? Can't happen at the same time. So A is a student is male. B is a student prefers math. Are there students? Can you be male and prefer math at the same time? Yeah. Right? Some people in this class are that, right? Some males in this class are that, right? You can do both. I can be a male and prefer math, right? So are they, so if your answer is yes, I can do both, then the answer to mutually exclusive is no. No. Another way to check is look at this guy right here. If that guy that I just boxed in red, if that guy is anything other than 0, your answer is always going to be no. If it's 0, then your answer is yes. Okay. Are they mutually exclusive? Well, no, if they share something in common, right? This is the shared part. A and B is shared. What do they share in common? Well, they share this. So if they share something, they can't be mutually exclusive. Okay. If this is 0, yes, mutually exclusive. Okay. If I changed it, let's say I said A was prefers math and B was prefers English. Yeah, you can only prefer one, right? You have to prefer one over the other. I might like both, but one has to be a preferred, right? You can't prefer both. You only prefer one, right? That's like saying I prefer to sit in the front and I prefer to sit in the back. Well, you can only sit one place, right? You can only sit one place. So that's mutually exclusive. Okay. All right. General addition rule. General addition rule. A survey of all students at a large high school revealed that in the last month, 38% of them had dined at Taco Bell. 16% of them had dined at Chipotle. And 9 had dined at both. Suppose we select a student at random. What's the probability that the student has dined at Taco Bell or Chipotle in the last month? Reading that whole thing, what's the one word that's going to help us the most? Or. There you go. Or. If they say or in the question, that's the question, right? They want to know this or that, right? That's general addition rule, right? On your homework, on tests, they're not going to say there's not going to be a thing up here saying use the general addition rule, right? These are the notes. So those are the little things you look for. Okay, those little things you look for. That means or. So what I'm going to do now is I'm going to write out the general addition rule. Okay, because I know I'm going to use it. Okay. So now we have to figure out what A and B are. What could A be? They don't tell us what A and B are like they did the last one. So we have to come up with our own stuff. So what could event A be? Taco Bell, right? Here's the thing. I don't like using A's and B's because I like to put them in context. So what I'm going to do is I'm going to rewrite this formula except use T and B for Taco Bell and C for Chipotle. So I'm going to rewrite the formula. T, B, or C. TB means Taco Bell. Chipotle is C. So I'm going to rewrite the formula. It's the same formula, but I write it with different letters because they make more sense to me than A and B. Do you have to do this? No, but it helps me. If I see A and B, I don't see A and B anywhere in the question, but I see a TB and I see a C, right? So that's what those are. So it's the same formula, just in context. Okay. So what's the probability that a student has eaten at Taco Bell in the last month? 38%. I'm going to change it to a probability, so 0.38. What's the probability that a student has dined at Chipotle in the last month? 16. I'm going to change it to a decimal. Minus both. 9%, right? Both is 9%, 0.09. Do a little bit of math, and what do we get? You add those up, you get let's see, carry 4 minus 0.09, and we get 0.45, yeah. So that's the probability of Taco Bell or Chipotle. Okay. Use a different color for the or, so the and. Okay. So that's how we use formulas. The question before, we used a table and formulas. So you're not limited to using just one of these guys. You can use a couple of them, okay? You can use one or two of them or three of them. Sometimes three of them helps, okay? So now let's do a Venn diagram. Let's do a Venn diagram problem. Okay, so what I want you to do now is read the question and do A. Read the question and do A. Because you guys have done Venn diagrams before. Venn diagrams are two circles. The two circles. All right, the two circles that overlap. So we're going to write numbers inside. When you write numbers inside, don't write percents. Change them to decimals.
So when we write them out, we always have to change them into decimals.
Mm-hmm. The only time you use percents is when you're interpreting. When you're interpreting something like we did earlier, that's really the only time you're using percents. We can't, because percents, you can't really, you don't really want to add percents or multiply percents or divide percents, because percents aren't really useful when you're doing math. They're more of, how do I explain it to somebody? Instead of saying you get 0.4 off, you say, oh, there's 40% off. That's the only reason why we use percents. It's a little more user friendly. But when you're actually doing math, percents don't help. Decimals and fractions do. Okay, so according to a recent report, Pandora and Spotify are the most used music streaming apps. A group of AP Statistics students surveyed all of the seniors in their school and found that 68% of them use Pandora, 38% of them use Spotify, and 24% of them use both. So when is a Venn diagram a good idea? When they've given you one, another, and both. Right? When they've given you this information, it sets up for a Venn diagram. They won't tell you to use a Venn diagram, but it'll be helpful. This problem, it'll be helpful because they say, okay, we have one thing for Pandora, we have another thing for Spotify, and then both. That's what a Venn diagram is for. Okay? So when you use a Venn diagram, always start in the middle. Always start in the middle. In between them. So what number is going to go in between the what is going to go in here? What decimal is going to go in there? 0.24, I agree. 0.24. So now we're in the bigger circle. So I have a P, this is Pandora. This circle represents Pandora. And this circle represents Spotify. So in the Pandora, how much should be in the Pandora? 68%. So do I write 0.68 like this? Or is it something different? Yeah, most people will do this, what I just did. Why is that wrong? Well, what is this? So remember, this whole circle here is Pandora. How much should be in that whole circle? 68, right? 68, that's it. 68% should be in that green circle. Right now, I have 68 plus 24. That's over 68. That's not correct because it's not 68 plus 24. It's only 68. So this number here needs to be changed. Because I'm already accounting for those 24%. Those 24% use Pandora. I'm already accounting for them. Who are the ones that only use Pandora? So I got to go 68 minus the ones I've already counted. 40. So 24. So it's 44. So the one that's going to go in here is 44. Because in the green can only be, anything in the green circle can't go above 68. Okay. Now in the yellow circle is Spotify. We can't go above 38. Well, I already got 24. So that means that means 14, right? 14 has to be there. Okay. How much do those add up to? The numbers inside on the inside. 0.82. So we're missing some, right? Because it's got to, if you're going to include everybody, we're missing some. So how many are we missing? What percent are we missing? 18%. Who are they?
People who don't listen to either.
People who don't do either. So we put them on the outside. Okay. We put them on the outside. Now there's 100%. I know exactly where everyone is. 100% of the people. And that's the question for B, right? B is this. The probability of Pandora, sorry, not Pandora, and the probability of not Spotify. Right? That's what that means. Not. And that's what that little, remember from yesterday, that's what that little C means. C means that little C that looks like an exponent, it means not. So this is what they're asking. The probability of not Pandora, nor, which is another word for and. It's a negative, it's a word, another word for and in the negative. Spotify. Right? This one we don't really have a formula for. So we have to look at our picture. So who are these people? Who are not Pandora and not Spotify? That's the outside, right? That's the people who don't do either. Okay, that's the people who don't do either. Okay, let me give you another one. I'm going to give you another one. Call this C. What's the probability of Pandora and not Spotify? What's the probability of Pandora and not Spotify? So Pandora doesn't have the C, so it is Pandora. Look at the table, see what you come up with. So it's somewhere on this table. Somewhere on, let me make a little box for this so we don't. Okay, so I'm looking for Pandora. Okay, so where's Pandora? In the green. So I'm in the green, right? I'm in the green. So right now, I'm right here in the green. So not only in the green, but also not like Pandora, or sorry, Spotify. So which of those two don't like Spotify? 0.44. Yeah. Right? Pandora means I have to be in the green. And also not like Spotify. Well, 24 is actually in the Spotify circle, so I don't count that. 0.44 is that one. Okay. Let me give you another one. Let me give you an or one. Probability of not Pandora. Actually, you know what? Let me make it a little easier. Actually, you know what? Let's do that. So this is an OR one. Number 4 is an OR one. Give you a hint. Use the formula. What's the probability that a person is not Pandora, doesn't use Pandora, or uses Spotify? Okay, so the first thing, so I rewrote it out. So this equals the formula here. Okay, I just use the general addition formula, but instead of A and B, I use P, C, and S. P, C is not Pandora, S is Spotify. Okay, so first one, the probability of not Pandora. So this is everyone who is not in this green circle. If you are not in this green circle, I want you. So the ones not in this green circle are 14 and 18. Both of those guys, 0.32. Okay. Next is the probability of Spotify. Well, everyone who's a Spotify user is in here. So 14 plus 24 is 38. So now this is a tough one. Not Pandora and Spotify. Okay, so who did we say was not Pandora? Who did we say was not Pandora? This guy and this guy, right? This one's an and. So we have, so out of these two guys, which one is a Spotify? Only 14. So that's what we're going to put here. Okay, so 0.32 plus 0.38 is 0.7 minus 0.14, 0.56. So there's a 0.56 chance that if I randomly chose one of these students, they would be a person who either doesn't use Pandora or uses Spotify. Okay. Venn diagrams are one of the easier things to look at, right? You guys have been looking at Venn diagrams. I think in even like second or third grade, they show you Venn diagrams, right? They're very user friendly, right? You can tell a lot about them. But when you start including some of these C's in there, then you really got to kind of think about it. Not that one, right? Not P, not S. So you can do it, you just got to think about it, right? That's all it really is. So for this one, I used the Venn diagram that I made and I used the formula, right? Sometimes that works. On A, B, and C, sorry, B, C, and D, sorry, B and C, just B and C, I didn't need to use the formulas, right? I could just look at it. Again, using your resources. This chapter is all about using your resources. Don't be afraid to use tables and formulas. This is the biggest thing. This is the biggest thing I see. Biggest thing I see where students go wrong. They'll get a table like this, and then they'll ask a question. They'll ask the probability of the whatever, and they just try to use that. They refuse to use formulas. I can do it in my head. Sometimes you can't, okay? Sometimes you actually have to write it down, right? They're like, oh, I can do the formula in my head. Or I can do the answer the question in my head. I have the table. Sometimes you can, sometimes you can't. Okay, so don't be afraid to be able to use the formulas because the formulas will help you, right? The only one we've covered so far is the general addition rule. Next week, we'll cover the other formula, which is the general multiplication rule. Okay, that's the biggest mistake I see because I already kind of see it. When we were doing these kind of problems here, especially this one here, some of you were like writing down, some of you were just sitting there looking at it. And I know you could work it through in your head. You're trying to work it through in your head. Just be careful with that. because you're going to see some stuff, especially when you start seeing stuff like this. Not C, not S, not P. Write it down. Use the formulas. Okay, use the formulas. All right. Okay, so last problem. Last problem we done. Dorm room problem. Dorm room problem. Okay. So what I want you to do is do A. Do A right now. I'll give you a hint. You're going to use a Venn diagram. Okay, so a check of dorm rooms. I put this question because a lot of you are going to be like this a year from now. A year from now, you guys will be in a lot of you will. So a check of dorm rooms at a large college campus revealed that 38% of them had refrigerators in their room. 53% of them had TVs. And 21% had both a TV and a refrigerator. Okay, so start in the middle, 21. And then you have two circles, right? This circle is refrigerator. So total, that circle or oval should equal 38%. And then the other one is TV. This one in total should equal 53%. And then there were 30% left over. Is that right? 30% left over. That's fine. 0.30 is fine. 0.30, 0.3 is okay. Either one's okay. Okay. Okay, so what is the probability that a randomly selected dorm room has a TV or a refrigerator? There it is right there, or. Okay, if that's the question they're asking, don't even think twice. Just go right to the formula. So the probability of a refrigerator or a TV. Probability of a refrigerator plus the probability of a TV minus the overlap. Okay. Refrigerator is the green circle. Everything in the green circle is a refrigerator. So that's 0.38. Everything in the yellow is TV. So that's 0.53. The overlap is both refrigerator and a TV. There's 21% of people. So you add those up, you get 0.91.7. Okay. One or the other. One or the other. Remember, or means one or the other. Not both, because we subtracted the both. One or the other. Has a TV. You walk 70% chance you walk into this dorm room, this college in a dorm room. 70% chance you're either going to see a TV or a refrigerator. Okay. All right. Last question. Are TV and refrigerator, are those two events, probability of TV, probability of refrigerator, are they mutually exclusive?
No.
They're not, because there's people with both outcomes. There's people with both outcomes. Both outcomes are having a refrigerator and having a TV. They share an outcome. right? We know that probability, 0.21. Disjoint is the same thing as mutually exclusive. Sometimes they call it mutually exclusive. Sometimes they say disjoint. I don't know. They're the same. They're the same. They mean the same thing, though. They mean exactly the same thing. Disjoint and mutually exclusive mean the same thing. So sometimes on a test, you'll see disjoint. Like, what does that mean? It's the same thing as mutually exclusive. Okay. Disjoint is more of the probability term. Mutually exclusive is more of the, like, we use that a lot in our vocabulary. Okay.